Hey guys, how's it going? So in this tutorial I'm gonna show you guys how to provide a K-path for band structure calculations. So if you have ever had a look at any band structures uh, in research or literature, then you must have noticed that they are usually plotted along the high symmetry points. So let's just have a look at band structure of some popular semiconductor like CDSE. So if you have a look here, then you can see here that they are usually plotted along some high symmetry points like L, gamma, X, gamma, and so on. So here another plot, then we have another plot here, then here, okay, so this one looks for silicon, not CDSE. Then we have another plot here that is along like A, L, M. Okay, so this is one is for both side. Okay, zinc blende CDSE, then gamma, X, W, gamma, K, or so on. So these are basically the high symmetry points corresponding to a crystal lattice, right? So in case of silicon, we have an FCC lattice, and then in case of CDSE also we have a pretty much a diamond FCC lattice, I guess. So what we do is we just plot the band structures along the high symmetry points because they basically contain all the information. And in case you have some other lattice like the word-side lattice, then you have some other high symmetry points. For example, here the high symmetry points are like A, L, M, gamma, L, A, H, K, etc. So the high symmetry points usually differ, or I mean they differ with the type of lattice that you have. So the first step to know about the K-path that you'll be providing in your input file for the quantum espresso is to know that what kind of a lattice you are working with. So the first step would be that. Then the next step that you will be taking is, once you know the kind of lattice, then you can probably just head over to Google on whatever you want, or refer to some book, then you can find out the high symmetry points for that particular lattice. So let's say we want to find out the high symmetry points for the FCC lattice. So you'll just go over here or on Wikipedia, and then you can notice that they provided you with the high symmetry points as well as the path. So here the paths would be like gamma, X, W, K, gamma. And in case you have a look here, then they have followed a similar path like gamma, X, W, K, gamma. So they are following a similar path here. So that's how you will find out the high symmetry paths that you will be providing quantum espresso. Now the problem with quantum espresso is, or I mean one issue here is that there are three ways in which you can provide these high symmetry points. So the first way is the simplest way, that is you just basically write down the initials of the symmetry points and then the number of these points. So basically what quantum espresso does is it draws a line from gamma to X. So this is one high symmetry line, and then this point tells the number of points along this line. So you can either provide the high symmetry points in this way, or you could provide their coordinates explicitly. So there is another way, that is you could just write down the coordinates like 0, 0, 0, so the 3D coordinates of gamma point, and then just get rid of gamma. And if you click here, then these changes will reflect, and you will have these the coordinates. So there are till now we have discussed two ways. Now the thing is that these coordinates currently are in the units of 2 pi by a, which is denoted by here. So we are currently entering the coordinates in 2 pi by a units. However, you can enter the coordinates in crystal units as well. Now in case now you are wondering like, I knew the coordinates for the gamma point, but how do I know the coordinates for the X, M, gamma, or any other point like W, X, W? Again, Google will be of service to you, and you can just Google that like high symmetry points for FCC lattice, and then go to any link, and here you will find the coordinates for all these high symmetry points. So you can see that X has the high symmetry coordinates like 0, half, half in the crystal coordinates, but 0, 1, 0 in the 2 pi by a units. So you can enter those here, and so on. So that is how you will in principle provide the high symmetry points to quantum espresso input file for the band structure calculation. Okay, so I hope that answers your doubts and any questions that you had. And in case you have any other doubts and questions, then leave them in the comment section down below. And I hope you guys enjoyed this video and found it useful. And in case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.